Hey, what are you doing there? Come with me. This is the Soil Ecology Lab. Hey, Madeline.
Hey, Rorik. I'm the Soil Ecology Lab Manager. Our team researches soil and how prairie plants and crops affect soil to improve soil health on farmers' fields.
But why study soil? What's so important about dirt?
Good question. Soil is the foundation for all life. All the living things that we see here, from the birds to the plants to the insects that we hear, even you and I are reliant on the soil for our survival.
Soil is the foundation of life on land. It is the habitat, food, and water reservoir not only for plants, but for billions of organisms that live in every teaspoon. Soils form over millions of years, with new soil formed at less than the width of a human hair each year through the chemical interactions of water, rock, and living organisms, changing the soil all the time.
These grasses are not only alive because of the nutrients that are in the soil, but their root systems are actually helping build the soil itself.
Okay, so the prairie relies on soil, but why should we care? I don't live in the prairie, and I thought we focused on breeding perennial grains at the Land Institute.
Good question. Actually, you and I rely on healthy soil just as much as the rest of the prairie ecosystem. So agriculture depends on healthy soil to grow most of our food, from our grains, to our vegetables, to our livestock. Without soil, we wouldn't be able to produce most of the food that we eat.
Unlike the prairie ecosystem, these agricultural systems are not building soil. Every time we plow the soil, we break it up. Being exposed like this can cause soil to erode and become less healthy. Perennial grains, like kernza, help build soil health because they have long roots that stay in the soil year-round, like the prairie.
Wait, how do you even tell if soil is healthy?
Good question. Let's head back to the Soil Ecology Lab, and I can show you one of the ways that we measure soil health.
Wait, I was about to...
Basically, healthy soil is any soil that supports life, from grasses in the prairie to crops on a farmer's field. There are lots of different things that we could study to understand soil health, from soil carbon to porosity and compaction to soil nutrient concentrations. But for now, let's focus on something called aggregate stability.
Aggregate?
Yes, aggregates are granules or little clumps of soil that stick together. They come in all different shapes and sizes.
So, kind of like a mud ball.
Well, not exactly. Aggregates form naturally in the soil. Here are a few examples. Aggregates are held together by the sticky things in the soil, so like clays and juices that are released by plant roots and fungi and microbes. Aggregates form differently in different types of soil as a result of texture and soil age and many other factors.
Each aggregate creates an environment that can house different kinds of organisms and protect organic matter.
What about the stability part?
That part is about how well the aggregates stick together and resist breaking into smaller pieces. Soil with stronger aggregates tends to be healthier for several reasons.
Like what?
This soil has perennial plants growing in it with long roots that help build stable aggregates. Water moves through the pores around aggregates, making it easier for water to infiltrate the soil with less of the soil washing away. This pot of soil has been tilled, so the aggregates have been broken. The water moves more slowly because the space between the soil particles is smaller and the soil is not sticking to itself, so it gets moved or eroded as water moves. Once the aggregates are broken, the organic matter and nutrients that were inside are now exposed and are easily lost from the soil.
Aggregate stability does seem pretty important. How do we measure that in a lab?
Let me show you. This is our soil aggregate analysis machine, or SAM. We use it to study aggregate stability in the lab. So first we take the smallest sieve size, then the next sieve size, a larger one, and the biggest goes on the top. And now you'll pour that soil that we weighed out into this nest of sieves. Then we take our nest of sieves and we put it here in this bucket of water. Then we turn on our machine and we run it for 10 minutes.
Okay. But won't the soil just break apart when you dump it in this water?
Good question. This is what it looks like when we pull it out. And this machine helps simulate the process of erosion. So it distributes our different aggregate sizes, with the largest on the big sieve and then the smaller ones below. Next, we'll take this tap water and we'll rinse the aggregates off the sieve into this loaf pan that we'll put into the oven to dry, and then we'll weigh it.
Okay. Thanks for teaching us. But what do I do with this mud ball?
It doesn't really matter.